Alright, and welcome to Exponential Equations Level 1. Now in this very first example, we'll be solving for x, and take a look at this. We have 64 to the power of 3x minus 8 is equal to 512 to the power of 6x minus 11. And initially this probably looks like a pretty difficult problem. However, if we know just a couple of basic facts, it becomes incredibly simple. So let's see. Let's first take a look at 64 and 512. We want to turn these two bases into the same number. Can you think of a number that both 64 and 512 share? Well, I would always recommend that you memorize your squares and your cubes through 15, and it turns out that 64 is actually 8 squared. And so I'll change 64 into 8 squared, but we still have to raise it up to the 3x minus 8 equals, and we should know that 512 is actually 8 cubed, and of course we'll raise this up to the 6x minus 11. Now from here, here's a very cool thing. Whenever your bases are the exact same, you can actually ignore them. They don't cancel. You can ignore them and simply set what is up in the exponents equivalent to each other. So let's kind of do two things here. One, we're going to ignore the 8, and two, let's distribute that 2, because when we have a power to a power, the rule is that we want to multiply. So 2 times 3x would of course give us 6x, and 2 times negative 8 would give us negative 16 equals, and over here we have 3 times 6, which would be 18x, and of course 3 times negative 11, which would be negative 33. And from here we have a pretty easy equation. So I would always encourage you to look at this equation, and if it has x's on both sides, I would encourage you to move the smaller x first. So how do you get rid of that positive 6x? Well, we will subtract 6x from both sides, and of course that gives us a little zero pair there. And I'm even going to bring this up here to rewrite it kind of nice and neat. We'll have negative 16 is equal to, and we know that 18x minus 6x will of course give us 12x, and then of course I bring over that minus 33. Well, I see that my x is on the right side. I now have to get rid of my constant or my subtraction. And how do you get rid of a minus 33? Well, we can go ahead and do plus 33, and here I'll do plus 33. And remember, negative 16 plus 33 is actually the same as saying 33 minus 16. So what would that be? Well, 33 minus 10 would be 23, and 23 minus 6 will of course give us 17. So we have 17 equals 12x. And since we have a number in front of the x, well, how do you get rid of that? You get rid of it by dividing. And once we divide both sides by x, we get x equals 17 over 12. Just a very nice, easy example. Pause the video, finish writing down your notes, whatever you need to do, and let's go ahead and move on to our second example. Alright, so let's take a look at this second example. Of course, we're solving for x. And so notice, what is our problem? Our problem is that our bases are not the same. We need to turn them into the same base. And when you look at 25 and 625, this should be one of the more obvious ones. What is a base that both of them have in common? Well, in this case, the base that they have in common would be 5. And so how can you rewrite 25 as 5? Well, 25 is just another way of saying 5 squared. So we can write 5 squared to the power of 8x minus 3. And look, if you know that 25 reduces to 5 squared, but you don't know what 625 to what power it is, what I would encourage you to do is just take your calculator and just do 5 times 5, and that's 2. And then multiply by 5 again, that's 3. And then multiply by 5 again, that's 4. And so after you multiply 5 times itself 4 times, well, you find that it's going to equal 625. So, this is something that you can just kind of play around with your calculator and say, like, hey, I know that this one on the left has a base of 5 to the power of 2, and just start multiplying 5 by itself as many times as necessary until you find 625. It's really that simple. Now, once we've done this, this problem becomes extraordinarily easy. We know that once we have the same base, we can essentially ignore them, not cancel out, but ignore them, and we simply have 2 to the power of 8x minus 3. Well, a power to a power we multiply. So 2 times 8x will give us 16x, and 2 times negative 3 will give us negative 6 equals, over here 4 times 2x will be 8x, and 4 times 8 will of course be 32. Well, ask yourself, what should I move first, the x's or the constants? And let's go ahead and move my smaller x, so minus 8x minus 8x, and of course we now have 8x minus 6 equals 32. And from here we have a simple algebra 1 equation. How do we get rid of the minus 6? Plus 6 plus 6. And I'm going to go ahead and bring this up here to make it a little nicer and neater. We have 8x equals, and of course 32 plus 6 will give us 38. And how do you get rid of that 8? Well, of course we will divide. And as I look at 38 over 8, I realize something. It can actually be reduced. What can 38 and 8 both be divided by? Well, we can divide them both by 2. And 38 divided by 2 will give us 19 over, and 8 divided by 2 will give us 4. And there you go. Alright, go ahead, pause this video, finish up any notes that you need, and good luck with this assignment.